almost once a year, we get a total eclipse of the sun. And that happens because the moon is going around the Earth, and the Earth is going around the sun. And if you happen to be in the right spot at the right time, you'll see the sun disappear as the moon is blocking it out. When the moon exactly covers the sun, the sky goes dark, temperatures drop, so it becomes like an instant nightfall. And then you can see one of the cool features of the sun, and that's the sun's extended outer atmosphere. We call it the corona. Corona is a Latin word that means crown. So like a crown, the shape of the atmosphere of the sun has these kind of pointy rays coming off of it. And that's something that you can see during a total eclipse of the sun. And one of the things that's really cool about solar eclipses is that they're all different because the corona is always changing. And that's because the corona is itself shaped by the sun's magnetic field. And that magnetism itself creates all kinds of interesting phenomenon in the atmosphere of the sun, like solar flares and coronal mass ejections. Those things have effects on Earth called space weather. And we're very interested to try to understand, well, how does the sun make that magnetic field? What's the process that's going on that causes the sun to both have a magnetic field and for that magnetic field to change the way it does? What we'd like to be able to do is peer inside the sun, if we could, to try and understand how are the motions inside the sun creating the magnetic field and where exactly is that happening. NASA has funded a science center to bring people from all around the country who have expertise in trying to study the interior of the sun so that they can kind of work on this together. This science center is called COFFIES. COFFIES stands for the consequences of fields and flows in the interior and exterior of the sun. One of the reasons, of course, that we're really keen to try to understand this is we'd like to be able to predict that activity that happens then in its atmosphere that creates the solar flares, that creates the CMEs, because those create, again, what we call space weather. When those types of events impact the Earth, they can create reverberations in Earth's magnetic field as well as impacts in our atmosphere. And all of those things are important to our technological society. They affect our communications, including our GPS satellites. They can also create havoc in our electrical grids on the surface of the planet. So this is the kind of thing where we want to be able to make these predictions of when a storm is coming so that people can get their technology ready. And our space travelers. We now have astronauts who are heading back out to the moon, for example, on the Artemis program. We want to be able to predict when is going to be a safe time for astronauts to go to the moon, when is a storm coming, so that the astronauts can either take shelter or plan their trip around the storm. So space weather prediction is really important to us now, and being able to predict space weather begins with being able to predict what's the sun going to do. And we're only going to be able to understand when the sun's going to produce a solar flare or a CME if we can understand how it actually generates its magnetic field in the first place.